This is an unnecessary step if you can see everything. Cosecant squared x dx minus sine x dx with the same boundaries. So cosecant squared, first ask yourself, is there a trig function that has that as a derivative? Well, looking here, cotangent's derivative is a negative cosecant squared. So I need a negative. So I need a negative. Hitting it with a 1. And then sine, it would be cosine's derivative is negative sine. So I can bring that negative that's out here in, and I'm all set. So this one, the carry along my negative, cotangent x plus cosine's derivative is negative sine, and then I'm going to evaluate that from pi over 4 to pi over 3. So, check my mode, I'm good. So I need a, let's say I'm going to go to the y equals, because I've got to do 2 of them. Negative, cotangent is 1 divided by tan x plus cosine x. I want pi over 3 that'll be my first value. So a negative 0.0774 minus, and now I want the pi over 4. So I'll go back to table set. Started at pi divided by 4. And I get a negative, oh, this was negative, subtracting a negative 0.2929. And now I'll just come out and do that subtraction. Negative 0.0774, subtract negative 0.2929. I guess I could have just done an add there. Area under the curve is 0.2155. Ooh, see if I got the right answer. I didn't write it down. We're going to go with it. I don't think I made any mistakes in there. A couple more just to review the integration rules that we had in the past. When there's insides and having the derivative of the inside. Number 5. We are looking at the integral from 3.1 to 6.2 of 4x plus 6 to the 5th dx. Okay, there's definitely an inside here. You have to have the derivative of the inside attached to the dx in order to use the power rule. So this one's pretty simple. You don't need to do this part over here, but I will. The derivative of the inside is a 4 dx. So that tells me I need a 4 attached to the dx before I can do power rule. So I can multiply by 4 here, as long as I multiply by 1/4 out here, basically hitting it with a 1. So now 1/4, now power rule here. 4x plus 6, add 1, multiply by the reciprocal. No plus c needed because I'm going to evaluate from 3.1 to 6.2. So again, it's your choice what you want to do here. I like using the table because all I've got to do is type this equation in correctly one time. Or here if I plug in, I got to type a whole big line of stuff correctly. So this is my preference to solving, evaluating. So that's 1/24 times the quantity 4x plus 6 raised to the 6th. I want 6.2. So 6.2, you get 3.5. Oh, it's really big. It wasn't 3 point, it was, yeah, that was in scientific notation. Let's see. Oof. 355,70752. That was 35 million. 0.8685 minus. Now I want a 3.1. So go back to table set, put in the 3.1, grab that value. 1616946.67. So 35570,752 minus 1616946.67. 33,953,805.33. Lots of room for mistakes in there. Big numbers. Okay, our last one. The integral of from 0 to pi over 4 of cosine 4x dx. Okay, remember the angle is your inside function here. So the derivative is 4 dx. So I need a 4 attached to the dx, which means I need a 1/4 before I can integrate this. And now it's just a trig function. Which trig function has cosine as its derivative? And hopefully you remember that that's sine. So the integral is going to be 1/4 sine 4x evaluated from 0 to pi over 4. So y equals 0.25 sine 4x x pi over 4 pi over 4 is a 0 minus plugging in the 0 0. What the heck happened? Did I get 2 zeros? 1/4 sine 4x. Oh, honest to God, it's our last one too. What did I do? Pi divided by 4 is a 0. 0. Well, I don't know what happened here, because there should be some area under that curve. Let me check. Oh, I'll figure it out later. Your assignment for tomorrow is going to be page 224, Quickie 1 through 5, and then all of 1 through 22. Oh, I think I know. This one should have been in tomorrow's. I think I know what's going to happen here. Okay, but I'm going to check it afterwards. Oh,